Welcome everyone to today's Fairblock demo showcasing the auction module on Fairblock's testnet, FairyRing. My name is Hash Titan. Y'all can call me Hash. And today we're just going to be going over just a quick run through of what the auction module provides as a native function within FairyRing, and as well as a quick demo showcasing it in a sealed bid auction on a terminal app. So the quick rundown of the auction module is this. So there's currently two main types. There's more being expanded upon and will be released soon by our engineering teams in the ecosystem. But for now, there are timed auctions, which are covered in this tutorial based on block height. And there's also general auctions as well, which are something to be covered in the future. Essentially, time auctions are based on block height, similar to how in previous tutorials and within our docs and elsewhere in other applications, you can see encryption using block height as the ID associated to TIB, the current confidential computing method used within the FairyRing testnet. But of course, other methods can be used as outlined within our documentation. And then the general auctions aspect is using more so like general conditions that are defined within smart contracts. So using CosmWasm, this is more advanced. And those conditions would basically correspond when someone's going through an application that has general conditions defined within that smart contract. Those general conditions and that transaction altogether would be corresponding to a unique ID that is associated to and recorded within the FairyRing network, and uses TIB again to then provide the encryption and decryption associated to it. So again, today we're just going to be covering timed auctions though, and you'll see a leaderless sealed bid auction go through when we go at the code. And then as for other comments, yes, like basically the auction module is a native functionality for FairyRing. We've covered encrypted messages, we've covered general conditions with public decryption roughly, and then more detailed in another tutorial will come later. But then we've also covered general conditions with private decryption, and now we're covering the auction module with all these different confidential computing Lego blocks offered within the native functionality in FairyRing. One can actually build like very innovative confidential apps or cApps. And some ideas that we're exploring with other teams and developers include, but aren't limited to, dynamic pricing for intent mechanisms and fixed rate lending with leaderless auctions. You can find more in our ecosystem page, which I'll have a link to within the docs and the README for this repo. And with that, let's just jump into the actual code. Cool. So here you can see the repo that you're going to be cloning. It's the FairyRing repo, which is hosted under the Fairblock GitHub organization. And we're going to be using the feat/auction branch. Right now, we're just looking at a branch for the README to be updated on that respective tutorial branch. And within this repo, you'll find what we're going to really be covering is this bash script, which is essentially covering all the interactions into a local devnet. And I should have backed up a bit. Like with sealed bid auctions, you can read this and get a better understanding of everything that we kind of covered, but also just more information. But essentially, with sealed bid auctions, what are auctions, right? In the blockchain, we typically have transparent transactions, and a lot of what Fairblock offers is a way to solve this in a manner that provides more performance and more opportunities in the blockchain space. As we have like institutions and other actors that are more wary to actually act within the blockchain with everything being so transparent. So we need a way to have like conditional encryption in a compliant manner. So essentially, what a sealed bid auction is compared to what a let's call it like past Web3 auction would be. So a past Web3 auction, they would have no encryption at all. And so you could clearly see what other people are actually bidding. And then thus, you could arguably like kind of front run other people's auctions bids, and I could just see your bid and just get ahead of you, and that's that. And when you apply auctions into other aspects, such as let's say solvers within a intent-based protocol, such as like CowSwap, then you can actually use sealed bid auctions in an interesting way to provide fair price discovery for the respective bid, or for the respective intent that the solvers are trying to bid on, which is an interesting paradigm in itself and just like the tip of the iceberg when looking at sealed bid auctions in intent systems, for example. So with that quick like rundown, this tutorial honestly is very straightforward in terms of running it. All you do is clone the actual repo accordingly, get into the respective branch, as mentioned, the auction branch. And then you're going to be spinning up a local testnet. If you've gone through some of our tutorials already, you know this is like a typical pattern when actually going through these FairyRing demos and tutorials. And then from there, you're going to be running the test sealed bid auction script to go through a couple different checks and then carry out an actual auction based, a timed auction based off of block height and see that the transaction carries through successfully. And I understand that we're just ripping through things quick, but I definitely advise you to check it out on your own time more. But essentially, the main aspects that are covered within the demo are the creation of an auction, the attempted registration of a bidder with insufficient funds, the successful registration of a bidder with sufficient funds, quick tests and resultant echo statements for testing the deregistration of that bidder, testing the auction with no bid, so it'll resolve automatically in that situation. Um, and then testing the timed auction with single bids, finally actually showcasing that it works, and then testing the non-registered bidder being rejected. So you can only have like, registered bidders actually carry out bids, and then testing the bid with an invalid bid amount, where it's greater than what the bidder's actual amount is, so it'd fail. Cool. And when working with the auction module, there are some important facts to keep in mind. So one, to bid on an auction, a user must be a registered bidder. Two, to register a bidder, users need to make a transaction and stake some tokens. So if they submit a faulty bid, the staked amount is forfeit, and accordingly to encourage proper operations. A bidder, once registered, can bid all they want. They can choose to manually deregister themselves, as mentioned before. And when the target height is reached, sealed bids are automatically decrypted, and the winner is the person with the highest bid. And we're not covering this really here, but in case of manual auctions, the same thing happens, but it's triggered by transaction from the auctioneer. So in this timed auction, there is no leader, so it's leaderless. Awesome. And then we'll jump to the code right away, but I wanted to touch on this is another part of the README and within the docs that I highly recommend checking out. So this is just covering the details of the auction module. If you're trying to look at, okay, like what are some of the commands covered in the bash script and what is going on there, this is laying it out in a sequence that makes sense to understand the overall flow when working with auctions. So here you have like the bash commands that are interacting with the respective functions and sending the respective messages to the module to be processed. You have further information in these toggles showcasing like the details of the transaction and details of that respective step. So it covers everything from creating the auction all the way to actually resolving it and checking the results. Cool. With that, let's jump to the code. So here you can see the bash script that I've been referring to. And within it, you can see the respective commands of actually like starting the auction. So create auction, for example, specifying the target height, specifying that it's encrypted or sealed bid auctions, and what currency is actually being used or token is being used. Again, these are all detailed more so in the end of the README, so I won't cover them too much in detail. I just want to run through the demo quickly. And I've already ran the commands to actually start up the local devnet, and I've already ran the command to actually run the script. So we can just look at the script results and compare to what's happening here. Cool. Okay, so essentially, as mentioned, to do. aside from setting up everything, we register a bidder with insufficient funds to delegate, and then we're checking like, hey, did the transaction fail with insufficient funds as expected? So you can see that here, failed as expected. And then moving on, we then go to register the bidder with proper, successful, sufficient funds. And here you can see the actual carry out of the bidder with sufficient funds. Perfect. And then we actually query it to actually see the bidder's information, which is obviously a helpful piece of information to use when developing your own application. Moving along, we then actually like test deregistering the bidder, and you can see that it's actually carried out manually successfully within the bash script, which is good. And finally, we then start testing the timed auction, but with no bid. So it resolves automatically. No bid, all the auctions. Here you go. Here's all the information. So you have the creator address, the identity of it all, the pub key that's used for encryption, and the resolution block height, as well as the denomination of the currency used or the token used within the bids. Cool. And then we finally test the auction with an actual single bid. So we're going to create a new auction here, as you see, specifying a new target height, so just the current block height plus 10. And then from there, we actually, just like every other tutorial, so that's kind of why I'm going through it very quickly, because it's covered elsewhere. We're using the same methodologies of local encryption using FairyRing, and then furthermore from there, the transaction will get decrypted and shown later on. So we're using the pub key, associate pub key to do the encryption, placing the bid with the now defined actual encrypted bid. So bid equals FairyRing the encrypted bid, etc. So here we're actually carrying out the placement of that bid in this respective auction. And then once the bid's actually placed, we use querying methods like list auction to see the details of what's going on. And here you can see there's a decrypted bid actually shown once the bid is done. And you can see the bidder and the amount actually done, carried out by or bid by them appropriately. And from there, you can see that the balance after settlement is XYZ. So there you go. That's great. And then finally, there's furthermore testing to see if, hey, can a non-registered bidder actually bid? And you can see that they cannot. And finally, once the bid is carried out, so once the placing all the bids, you can actually see that the auction is carried out properly. And checking it through here, it shows like the actual like balance changes of the bidders accordingly. And that is the completion of the auction. So you can see that the actual auction increased by 1 UFairy. The balance of the bidder has reduced appropriately as well, and they have actually successfully won the auction. And within this FairyRing repo, you can see, right, like the actual auction module and like dive in deeper. And as mentioned before, the README will actually cover like details corresponding to different aspects within it. So for example, when you're placing a bid, it actually covers like, okay, hey, the message place bid is processed and it's processed in the place bid function within the Go file. So I highly recommend checking that out further as well. Cool. So what are the next steps? Well, now that you actually understand some or you've seen the run through of a quick demo on auctions, I highly recommend that you join our Discord, check out our docs. From there, explore the tutorial more. As mentioned before, take a look at the toggle details referring to like the messages and the functions that are processing those messages to really understand the ins and out of the auction module. And then from there, explore novel use cases. Check out our RFP page, which is highlighted in our ecosystems page. You can find a link to it, and this is the RFP page. You can find different ideas in here. Definitely talk to us on our Discord to help add more ideas. And then in general, there will be a community contribution repo as well shared in the docs that you can contribute to too. And with that, that's the end of today's quick demo and tutorial. Again, reach out to me. My name is #Titan, the dev rel contributing to the ecosystem. You can reach me on Twitter as well as on Discord. Thanks for your time.